morning, class. My name is Diego. In our project, we use the SAP 2000 to design the bridge like everybody else. The truss bridge is one of the simplest and strongest bridges there is. While designing, we keep in consideration the forces that act on tension and compression that will affect the bridge and keep us into a safety factors, you know. Alan is what we got next.
All right, so we went over a bridge. Oh, I'm sorry, my name is Alan. All right, so the bridge. We use SAP to design a bridge, right? So we know what loads is going on in each member, and we use the values we get when we run an analysis on each member. We use those values to then create a bridge with a safety that will be safe for everybody. Can you go to the next one? All right, so in this procedure, we use the dimensions of a bridge. First, we need to calculate a cross-sectional area. Or that's one way to go about it. You have your member, you have a cross-sectional area, and use this to calculate loads. And like in our previous labs, we use cross-sectional area to calculate deflection. When you apply a load to a beam, you have reaction forces on either side, and it will cause a deflection. This is important because you want your bridge, your members to have an allowable deflection that will be safe to use in a bridge.
And also these numbers that you see from the ASAP files that we had for 15.75, that from joint to joint, and that 13.64 that in the highest between the highest joints. So we used that mentioned in the SAP file also steel A36. Okay, and we calculations we in the same file we will find that the cross section of each member will be 20 inches square. So yeah.
I'll go for this one. My name is David. For here we calculate the impact force. Like for example, if the for example if the front load of the truck is 8,000, like for the front wheels, and the two back wheels, each one is 32,000. So what we did is multiply the 8,000 by 0.27, which is the impact factor. So and yeah, we added to the original number or the original load, so it can give us like the total force that's going to be applied on this area, like the front axle of the truck. And the same procedure for the second and third axle of the truck, 32,000 multiplied by 0.27, which is the safety, the impact force or the impact factor, and added to the 32,000, which is gonna give us the 40,640. And we did the same thing for the seven
For each
case, like on each side, like each part of the bridge. Next. Yeah. Here in this diagram it shows, okay, this is when the truck is like the initial part of the truck is like touching the bridge, and the second case it has 2 axles, 3 axles, and so on. Yeah, so when we did the SAP 2000, we did the simulation for all these cases, and we combined them together, which shows the force is going to be on each member of the bridge. So in this way we can calculate the total force on each member accurately in all cases, because I mean, like it's all cases. Okay, if like the truck just the first part, or like it's all loaded on the bridge, or like in the middle, or like at the end. So in this way we guarantee that we have all the cases that the bridge can go through. And yeah.
So this is an example of how we loaded the bridge. So, and this is a sample of the case of how the service calculation each member, how much is force or load carrying. So this is a sample of diagram of the ASAP. And
Hi everybody, my name is Mokhtar. As my colleagues say, we have like the objective is to construct this bridge. As we said before, this is each force is gonna be, we can see before as like tension or compression, but we take the highest one that's we used. In this case, this is as SAP 2000, give us like a good idea how to build this bridge. We have like, they give us like estimation about each member, how many sticks we can use in this case, and then if you can see here, this is the prototype started by counting how many sticks we got for both sides. The bridge like 126, for the road you got like 67. Yes.
okay, cost of
And this is the cost, the bridge, how we calculate. We have like, for example, for the concrete, we have like, we need to calculate the volume, which is the volume is equal the length multiplied by the width and the height, and then we multiply by the price. What the price is like, is it for the concrete is like, I remember maybe $50 or something per
yeah, it is here
bar.
for the concrete 50 per cubic yard.
cubic yard, and the same as for the steel. We have like the kind of the steel we use, like from example
A36.
A36, and the cost for the section area, we have the section area multiplied the length is going to be the volume the same multiplied by the price, and we have estimate the total price for the concrete and glass. Okay, next. And this is like as reference we use as label from the SAP. We have like it give us like idea how much cost the steel and kind of the flange and
Each
and
member,
from-
each
yeah,
member
each
of the
member,
steel,
each member, how many of them, and then you can add things. This is like little material, and the last one is gonna be that we give you everything.
And this is a picture of our.
I think this is
steel,
our
yeah.
bridge.
And this, okay, and this picture how they loaded the bridge and how they placed the bridge. Okay, they put this bridge is 2 lanes, and they tested each lane is separate than the other lane. So they loaded this lane with these old trucks. Okay, and they calculate how the deflection is, and it is in a allowable deflection or no. And after they finish this lane, they go to the other lane, and they go to the completely the full bridge also. They doing the 3 cases: this lane and the other lane and the full bridge. Okay. And there's some links that you can use for the American Code of Concrete Design and the steel code also. And thank you guys.